In this here example of brainwave activity, an EEG in this case, electroencephalograph, we see normal activity. Notice the peak right here. This peak is at 10 hertz in the alpha band. Then we have another peak in the mid-20s and around 22 to 28 hertz in the beta band. This is pretty standard healthy EEG. Notice how the theta and delta is indeed quite low. Now when we look at a head injury, here's a gray matter injury, and gray matter refers to the neurons themselves, as neurons are gray. When we look at white matter, which is networks as well as, in this case, we're looking at white and gray matter injury. So this is both networks, which have long axons that are covered in myelin, and that's why they are white, because myelin is a sheet of fat. It looks white. But we also have neuronal injury as well. And what we're seeing here, of course, is now high theta, very, very attenuated alpha and beta activity. Now, when we do an EEG, we use this type of an apparatus. We have a headband, as we can see in this picture here, on a person's head, and we pick up all the brain waves at these different sites. And we have frontal site, central, parietal, temporal, motor strip, occipital, prefrontal, and so on, and two ear reference electrodes called A1 and A2. Now, when we look at this here, notice the large delta waves that are showing up in this recording. You can see them there. And notice, though, that otherwise, everything is very flat otherwise. There's really no alpha to speak of, and there's really no beta to speak of as well. And when we process this into a compressed or into a spectral array, as we are here, notice the 1 to 4 hertz there is delta. Theta is in the 5 to 7 hertz range. Alpha is 8 to 12. What's called SMR or beta 1. SMR refers to sensory motor rhythm, and it's over the motor strip at C3 and C4, and it's 12 to 15 hertz. It's the idling rhythm for the motor strip, whereas alpha at 10 hertz is typically the idling rhythm for the rest of the brain or the main cortex, especially when our eyes are closed. Beta has to do with alertness and mental processing. Now we see in the 23 to roughly the 28 hertz range, there's a little yellow dot there over the left front. That's a little bit of muscle tension that got into the recording, and it shows up too as we get into the gamma band. Now notice the alpha is very attenuated as well as the beta. They're in deep blue, and the delta is getting quite hot from those low delta waves, those slow delta waves that are going on from both a white and a gray matter injury. Now here's what's interesting. And this is one of the issues with a lot of these head injuries that we're seeing relating to thalamocortical disruptions. Only 15 to 40% of moderate to severe close head injuries show detectable pathology on an MRI. In contrast to MRI, quantitative EEG, which you were just looking at with those color pictures, it's been shown to be better than 90% accurate in the detection of close head injury. And I think it's more like probably 98, 99%. This was done in 1998 when this study was done. Now in this lecture, I'll be talking primarily about interruptions of thalamocortical loops, and these do not show up on an MRI.